What up? I'm pretty sure I'm recording right now. But the beeps didn't go off. All right, let's do average value and then get into free response questions like we're going to see on the test. Yo, don't skip your free response questions. I gave you 4 free response questions that are going to be similar to the 4 free response questions you're going to see on your test. So, like, these 4 questions are part of your review for your test. So, like, we're doing it for our homework. So, like, there's no excuses for like I didn't know. I don't know what to study. We're starting now. Your quiz next class. Your quiz on Friday is 2 free response questions, 1 calculator, 1 no calculator. And I'm gonna give you 45 minutes for those 2 free response questions. We need like 15 minutes to grade it to make sure we're grading accurately to see how we're going to earn points. And we'll talk about that when we get to the free response questions. And that means we don't have much time to do practice problems. So for this new part, the average of something, I need you to know it. And then I need you to be ready for essentially like a practice test on Friday. Okay. So let's get to it. How do we calculate the average velocity? 2 different ways. Well, we started with an average rate of change of position, understanding that a rate of change of position is a velocity. An average rate of change of position would be an average velocity. Rate of change of position is velocity. An average rate of change of position would be an average velocity. So if I calculate the average rate of change of position from 1 to 4, I use the slope formula. This is like, just y2 minus y1, slope of a secant, feet per second, feet per second. But now, what we understand through our lesson 2, lesson 3 of this unit is that if we accumulate our velocity, it tells us our displacement, how much the position changes. We understand how we can find this with a calculator, and our calculator can accumulate. If we don't have a calculator, we have to understand what our positions are. We have to use an antiderivative. This is why an integral in your calculator means accumulate, because for hundreds of years, we had to antiderive to find an accumulation. All right, so I'm given the first question you should always have, like whenever you're doing anything, is do you have a calculator or not? Because if you have a calculator, things are easy. What's the average position? Well, like we are going to get to the point where like the average now of something. So I'm going to just put, I don't know, the average of P. Well, I'll accumulate P. Now, this is kind of the also idea of like, think about average like you did in middle school. How do you find the average of a set of numbers? You add them all up and you divide by the total amount of numbers. We are accumulating all of our values. We're adding them all up, and then we're dividing by essentially the interval, which is like the total amount of numbers in which we're occurring. So it's the same idea. We could transition from average rate of change and the translation of the rate of change of position as velocity to just like an average of something, accumulate that something, divide by the total. And then if we don't have a calculator, we have to take an antiderivative. So if I want to find the average position and I have a calculator, I'm just immediately plugging this in to my calculator. I'm not going to do a full sign analysis. I'm not going to do anything crazy. If I have a full sign analysis, great. Maybe that'll help you. But actually, it doesn't in this situation. I break out my calculator. Typically, we see it like this, or on the test, be ready for like this showing up. That way, we don't have to worry about like an integral and a fraction. So it's like 1/3 times this is equal to this divided by 3. But it's understanding like, again, it's just the same thing. So nothing different. I can math 9, 0 to 3 of, we're replacing t's with x's. X's don't mean position, X's mean time. In this situation, time is your X, position is your Y. Divided by 3, and that's my average position, negative 2.25. Done. I'm done. Now notice I didn't take an antiderivative. I let my calculator accumulate. What about the average velocity? Well, it's like if you have a velocity equation, I would just use it. Velocity is the rate of change of position. If you have a calculator, I would try to do as little amount of work as possible. I'd have the understanding of the accumulation of my velocity over the time interval to get the average velocity. Now I would do this. Now, common mistakes made when calculating averages is just getting your integral and forgetting to divide. Don't forget to divide. Maybe we put the 1/2 in front, doesn't matter. But now, let's talk about, without having to do a full sign analysis, how we calculate these things without a calculator, okay? So like, let's just not worry about the average rate of change. Rather think about an average of something being an accumulation of something over your interval. So if I want to find the average velocity from 1 to 3, I'm going to try to accumulate my velocity from 1 to 3. Okay? Now, here's the key, guys. If you don't have a calculator and you want to accumulate, you have to use an antiderivative. So let's think about this. The accumulation from 1 to 3 of V in my sign analysis can be found, because we're talking about V being a derivative, can be found by looking at the change in my position. I can use x of 3 minus x of 1. And this is what we did with the ideas of having plus c's, but not worrying about it because we'll know how much we increase or decrease. We will know what our accumulation is without having to do a bunch of math. You know, like we use an antiderivative without a calculator. You understand this means an antiderivative, okay? So you get the antiderivative of velocity, which is your position function, which is t squared minus 6t, plus c. But like if you have an ability to find said c, find it. It won't hurt you. It won't even help you, honestly, but it might be useful later. I then say, oh, this is position of time 3 minus the position of time 1, and then I'm going to divide that by 3 minus 1. Okay, so my position of time 3 is 9 minus 18 plus 2, which is negative 9 plus 2, which is negative 7. My position at time 1 is 1 minus 6 plus 2, which is negative 5 plus 2, which is negative 3. Now, this is important. The ending position was negative 7. The starting position was negative 3. Make sure we subtract them in the right order. We start at negative 3. We get to negative 7. We decreased 4. We decrease overall by 4. So this is going to be minus 4 over 2, which is negative 2. Yo, if you have your calculator, check your work. Let's make sure my accumulation of my derivative was correct. Cool. Divided by 2. Good. We got the same answer that we are looking for. The average velocity is this. Now let's go to the real kicker here. What is the average position from 1 to 3? So I would want to accumulate my position. Now, what is my position? Well, I found my position equation with all of its glory, t squared minus 6t plus 2. If you want to write above that this is like x of t, great. And this is v of t, great. Like accumulate your positions divided by your interval. Now, the sign analysis doesn't really help here. You don't find your position at 3 and your position at 1. How do you find the accumulation of your position? You actually either use your calculator or you use the antiderivative, which we'll call big X. You need the antiderivative of position. You need big X or big F if you're talking about F. That's rate of change, average rate of change of big X will be an average X. You don't have to understand that. Just remember, like, it's either you have your calculator or you don't have your calculator. If you don't have your calculator and you're asked to accumulate, you have to take an antiderivative. So we're going to get big X. I'm just going to write t small so it looks like X is really big. I get 1/3 t cubed minus 3t squared plus 2t plus c. Do I have a c? I do. Can I find c? No. But does it matter? It doesn't. Let's find big X of 3 and subtract big X of 1 and divide that by 2. So let's go big X of 3. That's going to be 27 divided by 3, which is 9 minus 27. Yep. Plus 6 plus c. So that's going to be negative 18 plus 6, which is negative 12 plus c. Okay, this is where I end. Where do I start? This is important. Remember, it's like we're finding like our displacement. So what did we do here? We know where we start. We subtract 4 to get to our end. We'll know where we start. How do we get to the end? You subtract these two numbers. That should make sense. We get 1/3. That sucks. Minus 3 plus 2 plus c. That's 1/3 minus 1. That's not that bad. That's negative 2/3 plus c. I go from negative 2/3 to negative 12. So subtract the 2. The c's won't matter. You can almost forget about them. Subtract the negative 2/3 from the 12. It's like, how much do I have to decrease? Well, this is 12, 24, 36 thirds plus 2/3. It's negative 34 thirds. I'll do the work here. Negative 34 thirds is the accumulation of my position, is big X of 3 minus big X of 1, divided by 2. How do you divide by 2? You multiply by a half. So that becomes negative 17 thirds. Okay? Now I have my calculator. I'm going to check. If I accumulated my positions, if I add up all my positions, my calculator is adding up all the positions with this integral. My calculator knows this as accumulate, not antiderivative. My calculator accumulates my positions to the best of its ability. We're dividing it by 2 to get the average position, which is the same as negative 17 thirds, unless I made a mistake. Nope, I didn't. Calculator does things quickly because it can accumulate. You have to use the antiderivative without a calculator. Cool. What's the average velocity? Like, we don't need a full sign analysis to answer this. Well, I could accumulate my velocities over my interval 0 to 6. Divide it by 6 minus 0. If you want to, put over the 1 over 6 on the other side. We have the accumulations of the velocity. We don't need to do anything really crazy. We don't need a full sign analysis, though. If we had it, it's easy to just like use it. You could, if you had it, find the position at 6 minus the position at 0. You could do this minus this over 6 using x of 0 is 7. You could use x of 0 c, it won't matter. But instead, 5 minus 3 plus 1 is the accumulations of my velocity. So that's 3. Divided by 6, I get a half. That's my answer. Yeah, I'm doing this on purpose. I'm giving you x of 4 is 72. You could find the average velocity over the interval by doing your position at 6 minus your position at 0. Your position at 6 would be 72 minus 3, which is 69. Your position at 0, it's like, well, 72 is, okay, sorry. Sorry, this is bad. This should be 4. My bad. Whoop, 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 whoop. You could do 72 here, and then your position at 0. Okay, well, 72, I'd have to add 3, I'd have to subtract 6, I'd have to add 2. Overall, I'm going to subtract 1, I'd get 71. So I'd have 72 minus 71, which is 1. Oh, wait, I don't have to do that because I'm given my accumulations. -2 plus 6 minus 3 is the accumulation of my velocity. So I get 1. That's your answer, okay? You don't have to take the antiderivative in these situations. It won't help you. You don't even have an equation, but you have the velocity graph and you have the accumulations, okay? All right, let's get to the free response questions. Here's the key to free response. First of all, make sure you know if it's a calculator question or no calculator question. That's a big difference. Yep. No naked answers, 3 decimal places for calculators. No naked numbers. That means a number can't just come out of thin air. You have to show the calculation you did in your calculator to get the number. Don't justify unless you're asked to. And when you justify, keep it simple. Less is more. Reference your derivative charts. Always reference signs or directions of derivatives. In this case, like velocities, accelerations, or x primes, x double prime. Okay, we have interval 0 to 6. We have a position. We have a velocity. We get an equation for acceleration. We have a position at time 0 is 2. Whenever you have a calculator question, just like we've been doing on our quizzes, the best thing to do is start by graphing your velocity. You got to make sure you type things in correctly with the proper parentheses. We like to graph y equals 0. We like to adjust our window from 0 to 6. We like to zoom fit. You hope for 1 sign change. If you get 2, you say shucks. My velocity is positive until this A value, then it's negative. I must be increasing a lot my position and then decreasing a little. I know where my max and my min is right now, but we have to talk about how we're going to justify that. Is speed of the particle increasing or decreasing at t equals 5.5? This is always going to be a question that you will see a reasoning being required. Now, we talk about speed having your velocity values go away from 0. That's positive velocities that are increasing. That means you're going 1, 2, 3, 4, 5, 6. You're going faster to the right. Or -1, -2, -3, -4, -5. You're going faster to the left. That is negative velocities that are decreasing. To keep it simple, we just say speed is increasing or decreasing based on the signs of velocity and acceleration. Now let's look at your velocity and what's happening at 5.5. Utilize trace. Trace allows you to go to any value by just like press trace, type in any value, press enter, and it goes right to that point. Press trace, I mean, we're already still on trace, so if I plug in 5.5, it'll go to that point. Now, what do I notice? My velocity is negative and my velocity is decreasing. There's so many ways to explain this, but you can see that your velocity values are getting further away from 0. So your speed is increasing. The simplest answer / justification is that velocity and acceleration have the same signs. You're good. Now, probably they're looking for the fact that the velocity at 5.5 is negative and that the acceleration at 5.5 is negative. They don't ask you for those values, but what if you wanted to find those values? Well, this is the velocity value. -0.453. the acceleration value, which is the derivative of the velocity. How do I find a derivative? Well, I have the derivative equation, so I could use it, or I could second calc my derivative at 5.5. If I plugged in 5.5 into this equation, I would get this value, negative 1.358. This is unnecessary. If you say speed is increasing and velocity and acceleration have the same signs and don't reference like what the values are, I have to give you credit for that. It didn't ask you what is the velocity, what is the acceleration, so you don't have to provide this. They didn't ask you what are the signs of velocity and acceleration, so you don't have to provide it. You can just answer the question as long as you reference velocity and acceleration have the same sides. That means speed increasing. If velocity and acceleration have opposite sides, speed's decreasing. I'm done. This is probably worth 2 points or maybe 1 point, having your justification and the correct answer. Part B, find the average velocity. Are you asked to justify? Are you asked to give a reason? No, but you can't provide a naked answer. So what do we do? Well, again, remember it's a calculator question. Let's accumulate all of our velocities. You should have DTs after this, but if you don't, they actually don't count it wrong, and divide it by 6. How do I find this with a calculator? I type it in. Now, you could either go into your home screen, and again, Math 9, type in the entire velocity equation, but since you already graphed your velocity equation in Y1, you can just say, yo, calculator, please accumulate my Y1 from 0 to 6. Alpha F4 Y1. You've never done this before? Guys, get with the program and do your homework. Great. Don't forget to divide by 6. This is your answer. You get full credit for this. This is maybe worth 1 or 2 points, maybe 1 point to use an integral, 1 point to get the correct answer. No naked answers. You can't just write down this answer. This has to be included. So we're at 3 points total. Part C. Find the total distance traveled. Ooh, I could use a full sign analysis if I wanted to. I could look at, and probably a lot of you when you're doing these questions are immediately throwing down, 0, A, 6, your derivative, your velocity is positive, then negative. That means your position is increasing, decreasing. You're probably thinking about finding these displacements, these accumulations of your derivative. This is the same as that, so I'm just writing both ways. You could find all this stuff. Whoops, this is 8 to 6. Silly head. I don't know why I'm doing this. Why do I say this? Why am I saying, why am I doing this? What am I wasting my time? Probably for a later problem, to be honest. But why am I doing this? Because you could say your distance is your accumulation from 0 to A of V minus your accumulation from A to 6, which takes this amount that we went up, amount that the particle moved to the right, adds the amount that we moved to the left as a positive. And you could get your answer this way. But what's the shortcut? What did I try to allude you to? You can just accumulate your speeds or make sure all your displacements are positive using an absolute value. Now, it's very hard to insert an absolute value, but you can. rewrite it over the y1, and then add in the y1. If you don't remember how to find an absolute value, math, go over to num abs. If you actually do your homework, you know how to do this. If you don't do your homework, well, you're learning it now. Plug in y1. I'm getting the same answer, 12.573. Takes a while to accumulate with an absolute value. Your calculator has to work hard. Notice it's a little bit less accurate this way, but we get the same answer. What would I do for the test? This. Yo, you just have to get the right answer and show how you got it. This is what I would do for the test. This is probably worth 1 point. Problems at work that you have to do more are worth more, okay? Don't leave parts blank because they're hard. D, the particle changes direction exactly once. Find the position of the particle at that time. We already found A. What was A? You got to write this down, guys. This is my bad for doing this. Like, if you're using A anywhere in your justifications or anywhere in your work, make sure you write down what A is. You got to write down somewhere A is 5.195, 5.22263. Okay? Boom, you have A. Now, since we did the sign analysis for distance, we know the particle changes direction at A. Now, like, what are they asking you for? Any justifications? No. Find the position of the particle at that time. So, you ready? We are finding the position at A. Okay, you have to show your work done. You can't reference this as your work. This is not your work. This is just helpful for you. We know x of 0 is 2. We will then add 12.143 to get x of A. We will subtract 0.438 to get x of 6. We'll do that for the last part. For this part, we just need to take 2 and add the accumulation from 0 to A, which we found earlier. Bam, 14.134. This is not your work. What you must do is say, I took my position at time 0, whether you use the number or not. I added my accumulation from 0 to A. Don't say y1 unless you write down what y1 is equal to. Say v or x prime. You can list off, x prime equals v somewhere, though it's kind of assumed that they're the same. So if you want to do x prime here, I'm giving you full credit for sure. And then you write down your answer. This is what you have to do on these calculator problems. So you show you know how to get this. 14.134. I'll accept 14.135. But I like to truncate. You have to be accurate to 3 decimal places, whether it's rounded or truncated. Truncated means just write the first 3 decimals and you're good. This is probably worth 2 points. This is probably worth 1 point to use an integral, 1 point there. Part E, when is the particle furthest right? I mean, I probably should change this to furthest left. But we know that the answer is, now we have to justify. There are 2 ways to do this, guys. There's a quick way that involves a lot of words. There's a long way that uses less words. I'm going to do the long way that I think is easier. You could say the max position is when your derivative equals 0, but like you could say changes sign. You could be specific about how it changes sign from positive to negative. You could just say equals 0 for this case because we're not going to have a crazy amount of candidates, or an endpoint. This is, you understand the extreme value theorem. This is where candidates come from. You then list off your candidates. You already wrote down how you found x of A. You do have to include, even though you know it's not going to be a max, if you do it this way, you need to include all of the candidates. You need to include x of 6, which equals x of A plus the integral from A to 6 under x prime, which is, what do we get for that? A to 6 is that little bit right there. You get 13.696. You then say max by your candidates test. What the hell is a candidates test? Well, your candidates come from here. You stated here are when maxes occur. Here are all of the endpoints and zeros of the derivative. I've checked all of my candidates. I found the max. Typically, you don't have to write by candidates test. You can just say that's the max. Okay? Or quick way, but you have to write more work. Quick way is by eliminating some of our candidates. Quick way is by saying, yo, I know the max has to be at A. And if this was a min, I would say, yo, I know the max has to be either at 0 or 6. But how can we eliminate the endpoints or eliminate the middle if I was talking about the other? You have to reference your derivative. You could say, since x prime or v is positive over the interval 0 to A, and since x prime is negative from A to 6, you don't have to explain what that means. This shows you know what it means. Like position's increasing, then position is decreasing. You can then say max must be x of A, which is 14.134. If I were to do a min, well, the min would be the same over here. You would just say, boom, there's my min. Okay, so by the candidates test with this statement that must be stated. Okay, if you were to do the min the long way, you would say the min is either x of 0 or x of 6, since x prime is positive from 0 to A and x prime is negative from A to 6. So it's kind of like you're saying, yo, I know I just increase and then decrease. I have to have a min either here or here. You know, it's kind of like you have to state the signs of your derivatives, and then you could say x of 0 is 2, x of 6, you have to show your work to find it, but I did it over there. 13.696, boom, there's your min. All right, so like I would say for this test, guys, this is the safest way to do it. You say a max or min is when a derivative equals 0 or an endpoint, and then you check all of your candidates with all of the work behind it, making sure like I have the work for x of A there, and then you win. You get all 3 points. This is usually worth 3 points. Yeah, there you go, 9 points right there. 3, 4, 5, 6, 7, 8, 9. All right, the next calculator question you should really try on your own. If anything, I would want you to move towards this no calculator question because the first 3 questions are really the same. So I'm going to try to just blow through this really quickly. Here, we have a velocity, so we've got x prime. We got a position at time 0. They did not tell you that x of 0 equals 5. Make sure you're able to turn that into that, okay? This is a position. This is a time. Time, position. Don't make a stupid mistake by saying x of negative 5 equals 0. That's not right. Don't do that. With all of these calculator questions, you can just go ahead and just graph the velocity, adjust your window. Zero to 3.5. You hope and pray for one sign change. If you have 2, you cry a little bit, but you'll be okay. It just involves more work, which is why like maybe the quick way might be helpful. It looks like we start at a 0. It looks like we're going to have one sign change. It's really the same thing as the last situation. My displacement, my position is going to increase by a lot because I'm looking at this area under my velocity, the area under the derivative, the accumulation of the derivative being the change in the total. This area here is not that much. I'm going to be moving to the right a lot, to the left a little bit. My position is going to increase a lot, decrease a little. Okay? All right. Part A, find the acceleration at t equals 3. All right. So v prime of 3 is the same as a of 3. How can I find that quickly and easily without having to take the derivative? Easy. Second, calc, dy dx, type in 3, press enter. That's it. That's worth 1 point. Now, you have to say v prime. You have to say, oh, this is the derivative of v at 3. You can't just say a of 3 equals. I don't think they'd accept that, you know? Say, I'm looking at the derivative at 3. Now, what do I not write? I don't type math 8. I don't say, oh, I took the derivative. No, just like v prime of 3. That's the number. Boom. You get your credit. Don't write too much. Find the position at time 3. Now, again, you could do a full sign analysis. However, be careful here. You got this a value. We have the endpoint with 3.5. They're looking for this value 3. 3 is in between a and 3.5. This is a great question because, you know, it's not kind of something what we've been doing. We've been kind of just looking at what's going on overall. We've been finding our positions overall. We've been looking at displacements overall, but they kind of want you to split this from a to 3 and then from 3 to 3.5. This is something you could do if you want to. But let's remember, guys, if I know the displacement from 0 to 3, if I know this value, I can just take this, add this value to get that. I don't have to split it up. It doesn't have to be done when we find the ending position, that you have to split it up into how much we go right and how much we go left. I could show you that if you did an integral from 0 to a and from a to 3, I'm just going to stop at 3. I'm not going to write this number down. I'll write down. That I would get the exact same thing as if I accumulated from 0 to 3. 3.029 minus 0.05 is 3.2. It's got to be 4. Yeah, 3.24. Okay, so remembering that, your position at time 3, I could just take my starting position and add my displacement over that interval, the change in my position, the accumulation of my derivative over the interval. And that's what I would do. I would just do that, add it to -5, and I win. Now, for a question that asks for maxes and mins, I gotta do everything. Evaluate the integral from 0 to 3.5 and the integral from 0 to 3.5 of absolute v. Interpret the meaning of each integral. It's very easy, right? This is the change in your position. This is the accumulation of the derivative. This is the displacement. What is this? This is the accumulation of your speeds. This is the accumulation of all your positive displacements. That's distance. So easy, this question. Guys, you're going to see on your test, there are some easy questions. I mean, I don't even know what I'm doing here. I have it right here. You can say v, you can say x prime, it doesn't matter. What is this? Displacement of the particle over the interval. That says displacement of particle over interval, if you're just copying this down. And then math, num, abs. Whoops. Again, it kind of overwrites the Y1. It's tough to insert. Takes a while. You're adding up a bunch of stuff, and your calculator sees a different kind of like process to add up things with absolute values because of like the sharp points. This is the distance particle traveled over the 3.5 seconds. It's 3.737. Distance particle traveled over the interval. Cool. Ooh. Second particle moves along the x-axis. Now we're starting to get to like some curveball questions. Like, and you're going to see some curveball questions on your test where it's like, yo, we might be talking about two particles. We'll see that towards the end as well. Here's the second particle. Here is its position. At what time t are the two particles moving with the same velocity? So we're asking, when is the velocity of one equal to the velocity of two? Well, how do I find the velocity of particle two? I take the derivative. Would I use my calculator to take the derivative? No, I would not use my calculator to take the derivative. X prime of 2 equals v of 2, which equals 2t minus 1. How do I find when this velocity equals that velocity? How do I find when two equations equal each other? I hope you remember this. We graph and find the intersection. All right, so bye-bye y equals 0, you're gone. You could also subtract and set it equal to 0. But like, when does this velocity equal that velocity? We already have it graphed in the correct window. I'm going to find the intersection of these two graphs. I'm hoping they only occur one spot, but you're going to be careful. Yep, one spot. Second, calc intersect, enter, enter, enter. Make sure you get to the intersection. Now, be careful, guys. Like, this is why we store x as a, because x is now stored as this different value. So t equals 1.570. What would they probably want you to show? You're probably getting a point for taking the derivative of position. You're probably getting a point for finding the value and setting the two equations equal to each other. What is the average velocity? Do I have a calculator? I do. Hooray. Add up all of your velocities. Divide it by the interval. Just like finding an average of anything. Y1 still Y1. I've already found the displacement was this. I just need to take this number and divide it by 3.5. This is so easy. Where's all the justifications? Where's all the worry? There isn't none any. Let's like crush this test, guys. I really hope that we're going to do really well on this test. Better than previous years because I made this unit 5 days instead of 4, so we understand. Finally, we have something where we have to justify. When are we furthest left? Now, I've already done the work. Forgot what the values were. Where I found A, where we changed directions. So boom. Now I know what this value is, and I'm going to keep this up here just for time being. My position's increasing by this much. My position's going to decrease by this much. I'm going to take that value and add the A to 3.5, which I have up here. I don't have A to 3.5. I have A to 3. Make sure you have the correct integrals. Oh, okay. I didn't even write this down correctly. So I need to A to 3.5 x prime. I have my position at 3.5. It's negative 2.156. Just grab the integral and do A to 3.5. Everything should make sense after I have it down. Negative 0.446. So I have -5. I increase by 3. I get to 3.2. I get to negative 1.7. I then decrease by 0.44. I get negative 2.15. Everything makes sense. So here's the long way. We're trying to find furthest left. The long way is a min of position occurs when the derivative of position equals 0 or an endpoint. You've established where candidates come from. You then list off all of your candidates, which is annoying if you have like a lot of candidates. You don't have that many, so it's no big deal. You have written down what A was, right? Did I write down what A was? Nope. Guys, whew, I'm going to run into some problems here. $2.802. Make sure you write that down somewhere. If you're going to use it, it needs to be written down. How did you find x of A? You had x of 0. You added your accumulation of your velocity. You added your displacement. You added your velocities times times. You added a change in position. You got negative 1.709. X of 3.5 is x of A plus the accumulation from A to 3.5 of x prime, which is V. And I got negative 2.156. This must be written. You must show the work in getting this. This does not count as work. This counts as like something that you can reference, but then you have to write down exactly how you're getting this, which we've been doing. Now, what would be potentially a shorter way? Min must occur at t equals 0 or x of 0 or x of 3.5, since the derivative is positive from 0 to a, and then the derivative is negative from a to 3.5. I don't think this is saving much time, but it can. Therefore, you only have to list off your 2 points. Make sure you write down everything there. Make sure you include -5. Make sure you then say the winner. Okay, min by candidates test, or just say this is min. All right. The other way you could also say quickly that this is the min is you could say miss must occur at x equals 0. Really, if your displacement, you can't say that actually. That's not, it becomes more complicated. That's the easiest way. You could say like, you could start referencing displacements, but you have to reference the displacement over the entire interval. You say the displacement from 0 to a is positive this. The displacement from a to 3.5 is negative this. Therefore, since like this is bigger than this, you don't even have to write that. Since this is bigger than this, we must start at a min. It's just complicated, more complicated. I think the easier way is to like eliminate something that you have to check by eliminating candidates by referencing derivatives, but like this is the safe way to go. But again, you need to provide this statement or you don't get credit, okay? All right. Velocity 0 at 0, 3, and 5. The graph has horizontal tangents at 1 and at 4. Areas of the regions are 8, 3, and 2. Now, this is like a little bit of a trick that you're talking about area. When you reference area, it's always positive. When we talk about areas always being positive. But what's going on here is the accumulations have to be positive and negative, okay? Stop it. No.
I already bought them. I don't want them. Hi, YouTube.
It's just buttering me up, and it's not working. It's working. All right. So areas are positive. Accumulations of negative values will be negative. Okay. So cool. A. Find both the time and position of the particle when the particle is furthest to the left. Justify your answer. They're starting right off the bat with the key problem. We're paying attention to this guy. So let's just break out our full sign analysis. Just do it right off the bat. Where do I have more space? Over here. I got 0, 3, 5, 6. Unfortunately, I have 2 sign changes. My derivative is negative, then positive, then negative. My accumulations are -8, 3, and -2. I started at a position of -2. My position is decreasing till I get a position of -10. My position increases till I get a position of -7. My position decreases till I get -9. Great. Now you know all your positions where you change signs. You know all of your candidates, but now you just have to say what you just did. Okay, so here we go. Here's the easy way, though it's going to involve some writing. It's easy, but it involves like more work and more showing. There's a way that we can eliminate some candidates. Like we're talking about a min. You know that x of 5 is not a min because the derivative is positive from 3 to 5. You know x of 0 is not a min because the derivative is negative from 0 to 3. If you want to write all of that, you can eliminate 2 candidates to have to write down. But probably keep it simple. X will be a min when its derivative equals 0 or an endpoint. Here establishes where your candidates are coming from. Here is your first value. Here is x of 1. You can't just write down the position. Sorry, 3. You have to show the work. You started with x of 0. You added the accumulation from 0 to 3. Just keep going. Might as well just finish off with the work. We got 5 and 6. We have x of 3 plus 3 to 5. We got x of 6, which is x of 3 plus 5 to 5 plus 5 to 6. Okay. -10. -7. -9. It's making sure that works. Subtract 8. Add 3. Subtract 2. -9. Good. All right. Min by candidates. Test. You tested your candidates. That came from here. You can't say min by candidates test unless you have this statement where your candidates come from. When is speed increasing? When are your velocity values getting further away from 0? 0 to 1, your velocity values are negative and getting more negative. 3 to 4, your velocity values are positive and getting more positive. 5 to 6, your velocity values are negative and getting more negative. 0 to 1, 3 to 4, 5 to 6. But what's your justification? V and A have the same signs. Right? Like velocity is negative and decreasing. That means if velocity is decreasing, the acceleration is negative. If velocity is increasing, acceleration is positive. If your velocity values are negative and decreasing, boom, same signs of V and A. If your velocity values are positive and increasing, same signs of V and A. It's just the simplest way to say it. Just remember it. This is the justification for speed. When is acceleration negative? Oh, back to your second derivative analysis. Your acceleration is negative when your velocity is decreasing. I'm going to reference that sign. Velocity is decreasing, or I could probably say acceleration is negative when velocity is decreasing. Write down the words, though. You don't have to write is negative. You can always do less than 0 means negative. Velocity is decreasing from 0 to 1 and 4 to 6. Was the average velocity of the particle? Yeah, sure. We have all the work that we need to do over the interval is the question. We got either this or that. The average rate of change of position, rate of change of position is velocity. The average rate of change of position is translated to the average velocity, but I kind of forego this. And I just now think of averages as being averages. An average velocity, accumulate, add up all your velocities divided by your interval. So here's the accumulation of all my velocities, -7. That makes sense. I started at -2, went to -9. There's that -7 from x of 6 minus x of 0. -7 over 6. You need to show your work. That's your work. What is the distance that the particle traveled? Now, here we go. You can't necessarily type this into your calculator, but they'd accept it. But let's say, and I do this on the test, so if you're paying attention, you're actually watching this video, you win. You're just fasting forward, you lose. I do say, hey, write an expression without an absolute value to write the distance. So like that's going to be on the test, which means I can't accept this because it has an absolute value. Without an absolute value, what would I have to do? Well, I'd have to add up all these displacements as positives, which means like I need to make this the opposite. I need to keep this positive, and I need to take the opposite of this. And that's what I'd want you to do for that kind of question is like, 0 to 3, make it the opposite. 3 to 5, keep it positive. 5 to 6, take the opposite so that it becomes a positive. Add them up, 8, 9, 10, 11, 12, 13. Okay, so like with an absolute value wins, without an absolute value, and again, v and x prime are interchangeable, I don't care. Put v everywhere. You should have dt's everywhere, but they don't care, so I don't care. All right. Big star. We're going to have to do this during lunch. This question is your really good Unit 3 type question. This question is the most important question of this homework. This question is the question most students will have the most difficulty with because you don't have a calculator and you have to do some work. Okay, so we'll do this question during lunch. Pause. All right, so like this question, this is what the question on your quiz and on your test is going to look like, where you have no calculator, a bunch of equations. You have to do all this stuff. This is very much similar to the question you'll have on the quiz and your test in that I'm giving you two particles, two situations. So I'm giving you the position of one particle, I'm giving you the acceleration of the other one, which means you need to understand like the derivatives for one and the antiderivatives for the other. We could start answering the questions one at a time if we wanted to, but it's probably good to just have all of your equations ready to be used. So let's look at my first particle's velocity, which will be t squared minus 4t plus 3. Let's look at my first particle's acceleration. Always want the x prime. Which is v prime, which is a. Cool. On the other side of things, understanding your initial velocity and position are 4, -8, which is very important. V of 0 is 4. V of 0 is -8. X of 0 is -8. We can take antiderivatives. So V would be negative 2t plus c. This is for particle 2. V of 0 is 4. So V of 2 is negative 2t plus 4. Remember, if you can find c, find it. If you can't, okay, we can't. Figure it out, okay? When you can't find c, you can still subtract values and see or change or see what the accumulation would be. Let's go backwards again to my position. It's going to be negative t squared plus 4t plus c. And then at 0, we get negative 8. So my position of particle 2 is negative t squared plus 4t minus 8. Having these, making sure you understand which one's which. There is my particle 1. Here's my particle 2, A, V, X. Circle them, whatever you want to do. Now that we have everything what we need, we can answer the questions. At time 1, are the particles moving towards or away from each other? Justify your answer. Okay. It's very important to understand towards or away from each other on a position axis. Now, this is like going back to when we first understood our situation. Position and then time floating in the air. It's not this is a time axis like when we do our sign analysis. The key is to figure out where are 1 and 2 located and how are they moving? Are they moving this way, but in this spot is 2 here, is 1 here? You might see this question in another situation. Like your key is you need to understand your positions, where you're located, and then how your position's changing, whether your position's decreasing or increasing, the velocity. So you need to find your position of both particles at 1. Let's find that. This is for part A. So I get 1/3 minus 2 plus 3, so that's 1/3 plus 1, which is 4/3. Position of particle 2 is minus 1. Remember, you square, then take the opposite. Plus 4 minus 8. So that's going to be 3 minus 8 is negative 5. Okay, now this is telling me on a position axis that particle 1 is at 4/3. Particle 2 is at negative 5. Particle 1's to the right of particle 2. How are the positions changing? How are the derivatives of position at 1? How are the velocities at 1? The derivative position, 1 minus 4 plus 3. Oh, shoot. That's going to be 0. Particle 1's not moving. Okay. If it was moving, great. But it's not. How is the position changing for particle 2 at 1? That's the velocity of particle 2. 2t plus 4. Plug in 1, I get 2. Okay. That means particle 2, which has a negative position and a positive velocity, is moving towards particle 1. So at this moment, they are moving towards each other. So my answer is towards. But why? Based on positions and velocities. You don't have to write more than that. Keep it simple. Based on positions and velocities. At t equals 1. Okay. On your test, I would be looking for this information. If you did not have this information, or at least looking at like the sign analysis of things, you're not going to get credit. The answer towards is not worth anything without the relative justification. So don't just guess towards, you'd be wrong. Okay, part B. What is the displacement of particle 1 and 2 over the interval 0 to 2? 0 to 3. So we want the displacement. Now, this is really easy if you have all the equations. The displacement of particle 1 over the interval 0 to 3 is the accumulation of our derivative. For 1 and 2, the accumulation of our velocity. But we also know that that's equivalent to my ending position minus my starting position. This is the understanding of if we're talking about 0 to 3 and we're looking at our derivatives, like the connection of these positions and the accumulation of my derivative, how these things work hand in hand. You can go this plus this to get this, or you could take these two and subtract each other to get this. You know what I mean? That's the connection. So like if you had a calculator, you can accumulate your velocity. If you don't have a calculator, you need x of 3 minus x of 0. So position of 1 at 3 is 9 minus 18 plus 9, which is 0. My position at time 0 is 0. That can't be right. (27 divided by 3). Oh, no shit. 0. Position at time 0 is 0. So the displacement overall is a great question. Is 0 for particle 1. And that's all you have to write. You don't have to justify anything. Do we move? Yes, we certainly moved. But we actually started at 0, and then 3 seconds later, we're back to the position of 0. X of 0 is 0. X of 3 happened to be 0. There's some motion in between. We have to go right and left, but we'll end up overall displacing 0. Let's find the position of particle 2 at 3 and the position of particle 2 at 0. Position of particle 2 at 3 is negative 9 plus 12 minus 8. Negative 5. And then negative 8. So particle 2 had a position of negative 8 to start. Then 3 seconds later, negative 9 plus 12 minus 8 is negative 5. If you go from negative 8 to negative 5, what happens? You decrease 3. Okay, so that's how we get that calculation. You subtract the 2, or you could just kind of like look and see if I go from negative 8 to negative 5, I added 3, subtract to find that, we're good. Good. 1 point for this one, 1 point for this one probably. This is probably worth 2 points. We have more points than we know how to do here, but I'm just like giving you all the different types of questions you can have. Part C, what is the average position of particle 2 over the interval 0 to 3? Okay. To find an average position, we want to accumulate our position from 0 to 3. Not our derivative, our position. Divide it by my interval. Add up all my things, divide by the total. What this means, since we don't have a calculator, this goes back to the beginning of the homework. We need big X. We need big X of 3 minus big X of 0. The average rate of change of big X, well, the rate of change of big X is regular X. So if the average rate of change of big X can be translated into the average X, the average position, we need the antiderivative of particle 2. So maybe if you want to do the work on the side, or you just want to go for it here, who cares? Here's particle 2's big X. Negative 1/3 t cubed plus 2t squared minus 8t. What am I doing? I'm taking the antiderivative of regular x. Negative 1/3 t cubed plus 2t squared minus 8t plus a c. This is where it's like I can't find c, but it's okay. When we subtract big X of 3, again, and if you wanted to do this, it's like X will tell me about big X of 0, big X of 3. If I subtract these two values, I'll know how much we have accumulated X. It's the same idea. This to this, the C's won't matter. We'll just subtract them. Okay, so big X of 3 is negative 9 plus 18 minus 24 plus C, which is negative 6, negative 15 plus C. This is where I end. Where did I start? Big X of 2 of 0 is just C. If I started at C and then I got to negative 15 plus C, I'm going to get a decrease of 15 over 3, an average of negative 5. That is my answer. This is my work shown. If you want to be a little bit better about what I just did, you can be. You can say that this is equivalent to negative 15 over 3, which is negative 5. I kind of need to show that I did big X of 3 minus big X of 0, but I don't think they care. We have these, so we're good with that. That's good. 3 points probably. 1 point for the setup, 1 point for the antiderivative, 1 point for the final answer. Sometimes average questions can be worth a lot. Sometimes average questions, the calculator averages, not worth like much at all because it's easy. The harder questions that involve more work are worth more. Find the distance that the particle 1 traveled over the interval. All right. To answer this question, we need a full sign analysis of my friend particle 1 and its velocity. I need to take the derivative, set it equal to 0. My derivative sign analysis is, oh, this is so mean. All right, it's not bad. We got 1, we got 3, which is the end. We got 0. Here are my positions that I need to find, which will help me find my displacements, which will help me find, it's going to be a negative, so it'll be a positive, which will help me find my distance. So like, how am I going to find these displacements from 0 to 1 and 1 to 3? I'm going to find my positions at 0, 1, and 3. I already found my position at time 3 was 0. I already found my position at time 0 is 0. All I need is my position at time 1, my position at time 1. I found earlier. Oh, that's really nice. It's 4/3. Yo, this is important. And whoever wrote this question did a good job writing it. Usually we use stuff that we found in the past for the future. This is an example of that. Position at time 1 is 4/3, which means my position increases 4/3. My position then decreases 4/3. What happened overall? We traveled 8/3. Now, how would I show that with all of the work? I would say I accumulated, this is without an absolute value, which may be something that I actually ask you to do. I've accumulated my derivative from 0 to 4/3, which is a positive value. And then I subtracted, sorry, not from 4/3, from 0 to 1. Then I subtract my accumulation from 1 to 3, and I get a total of 8/3. Now watch this, I'm going to double check that. If I accumulated my velocity not my velocity, but rather my speed, my positive displacements. That's t squared minus 4t plus 3. I should get that answer. 8/3. Now your calculator just does the best it can to add up all of these velocity values, or these speed values, really. But boom, I just got that right answer that way. What would you need? Just this. As long as you have the positions written down somewhere, actually they are fine to be used like this. And as long as you have the integrals written down somewhere, it's actually fine like that. So you know what these values are, so you can write down that you subtracted the negative out of the positive to get that answer. That's good. What is the particle 2 furthest to the left? All right. Sign analysis. Particle 2's sign analysis. Derivative analysis. From 0 to 3, we have a 0 at 2. Gosh, this question, who wrote this question? This is like all in it. This is great. If I plugged in 1, I'd get positives and negatives. So we do move to the right and to the left. I did find my position of particle 2 at 1. That sucks, but I don't need it. Well, let's find your position so that we understand your displacements, but we don't really need the displacements because you have your candidates right here. It's 0, 2, and 3. Your endpoints are when your derivative equals 0. Unfortunately, it says furthest left, so whatever. It's easy enough to compare the 3 because you have the equation. This is negative 8. If I plug in 2, I get 8 minus 4 minus 8, so that's negative 4. That's good. That means I increased 4. If I plug in 3, did I find 3? Negative 5. So I did find some of these values, actually, right here. Okay, so I overall displaced 3, but how did I get there? I increased 4, I decreased 1. Gosh, this question is so good. This is so, like, if you're doing anything to study for your tests, to prepare you for this question, you do this question on your homework. I really crushed this question, to be honest. So here's part E. With justification. X2 will have a max when x2 prime equals 0 or an endpoint. X2 of 0 is negative 8. Sorry, we're not talking about a max. We're talking about a min furthest left. X2 of 2 is negative 4. X2 of 3 is negative 5. Here is my min starting point. By candidates test. What's the candidates test? It's like, here's where my candidates come from. Here are my candidates. Boom. This wins the candidates test. You don't need anything. Like, since you have the function for x sub 2, you have the equation. You just have to compare the values. When do the accelerations of the particles equal each other? I mean, that's easy enough to do. I don't know why I asked you this question. Maybe it's because it's on the test. I think it used to be on the test, but I changed it. The acceleration of particle 1 is 2t minus 4. When does that equal the acceleration of particle 2? I add 4. I divide by 2, t equals 1. At what time intervals are the speeds of both particles decreasing? Wow. Thanks, Mr. Master. All right, well, we got to do a sign analysis of V and A on top of each other. We already have V sign analysis for particle 1 and V sign analysis for particle 2. We just need A sign analysis, the second derivative sign analysis for 1 and 2. So A for particle 1 is 2t minus 4, so we're looking at 2 as a sign change. A's sign analysis, this is the second derivative of position, is negative then positive. Cool. What are we talking about? Speeds decreasing. Speeds are decreasing when the signs of V and A are opposite. So here is an interval. Here is an interval when these signs are opposite. We did V's analysis, x the first derivative sign analysis. On top of that, let's do a second derivative sign analysis for particle 2. The second derivative is negative. A is negative. So when is speed decreasing? That's from 0 to 2. When are both of them decreasing? 0 to 1 is when they both are decreasing. What is your response? What is your reasoning? What's your justification? The signs of V and A are opposite for both during that interval. And that's it, guys. This is your test. I literally give you the test for your homework. What do you mean? Your test is 2 calculator questions, just like these. Then 2 no calculator questions when one is like this and one is like that. Come on, let's do well on this. I really hooked you up with this extra day, space things out better. This last lesson, preparing you for free response questions. Let's do well, okay? Remember, no practice problems before our quiz, minor amounts of practice problems before our quiz on Friday, tomorrow. All right, later.